Hey everyone, welcome to this week's episode of the W.I.RE. We are streaming live from Mr. Godack's room today for Pi Day. And today we're going to have a special presentation on how to calculate pi from Hosmar and Spencer. So Hosmar and Spencer, you want to come grab your microphone? Oh yeah. Spencer. Should we share a screen? No, you're special.
Oh, we're both special persons. Is it working?
Go ahead.
It is? How to calculate pi. So what is pi? Pi is the ratio of the circumference of a circle to its diameter. In simpler words, if we were to get this line and close it to make a circle, it'd be the size of this. If we were to extend this one, roll it up with a pin, and then lay it flat, we'd get to that, which is around 3.14.
Okay. Now we're going to talk about a quick history of pi. Okay. So first, pi, the symbol for it, the Greek letter, if you didn't know. It was first introduced by a mathematician known as William Jones in about 1706. He introduced it like this because peripheria, right here, is the Greek word for circumference, and then the first letter of that is pi in Greek. So he said, okay, we're just going to use pi now. Why did we care about pi? People don't really ask this question. They just kind of accept that we should use it sometimes. As you know, with shapes and circles and stuff like that, it's kind of important for calculating circumference, area, volume. So architecture engineers, they love it. So like these good old ancient civilizations, they could get a very close proximity to what pi actually was, but without like a very accurate number of pi, it was hard for them to get like a very accurate answer to like what resources they would need or whatever if they're like building something. And then in like astronomy, pi is very important for calculating orbits and things. Architecture, we just talked about that. Physics and oscillations, pi is sinusoidal, so those. And then a little fun fact, today is also Albert Einstein's birthday. So woo, Albert Einstein!
Happy birthday! Okay,
a little check. Did anyone know what the sign of pi over 4 is? Okay, so like 80% of us have taken trig. What's the sign of Lydia! Yay! Okay, cosine of pi over 4. Anyone? Oh! Okay, so what's the tangent of pi over 4? 1! Okay, keep that in your brain. We're gonna use that. Okay. So grab a calculator. Okay. Are we all ready? Okay, we're gonna add some things. Okay. Okay, so we're gonna add 1. Okay. Then we're gonna subtract 1/3. Then we're gonna add 1/5. Then we're gonna subtract 1/7. Then we're gonna add 1/9. Then we're gonna subtract 1/11. Does anyone see the pattern here? Hopefully you see the pattern here. Anyone got the pattern?
Yeah, we see it, Steve. Gosh.
What's the pattern, Olivia Goldman?
Oh, don't ask me that.
What do you say?
We're going by odd denominators.
Okay, so we have, that's good. What's the other pattern here?
Oh, I can't do it that one. Oh, add, subtract.
We're alternating. So we're using odd denominators here. So we go from over 1, over 3, over 5. And then we're alternating signs. So +1, -1/3, blah, blah, blah. Okay, now add some more numbers. We're not going to do that. Okay, add some more. Just kidding. Oh, even more. Oh, no. Oh, some more numbers.
No, we're not.
Okay, so, okay. So eventually, if you keep following this pattern of adding and subtracting all these odd denominators, eventually we'll get a number kind of like this. Most of us have seen this number. We just don't remember this number. I'm going to ask you something. Multiply this number right here by 4. What do we get? What's our friend? Who is it?
It's pie. It's pie. Oh my gosh.
Pie. Oh my gosh, that's what pie is. Okay. Now good old question for you. Why?
Magic. Because it's magic.
Because it's magic. That's actually right. Okay. What else?
Spencer.
So,
Because that's pi over 4.
okay, so we're gonna move on. Raina is exactly right. So this is a little trigonometry of pi real quick. So this is called the Gregory-Leibniz method for getting pi. Okay? Now I'm gonna try and avoid a whole lot of advanced calculus here. Okay? Advanced that some of us and most of the others are gonna get into soon. Okay? So just trust me on this. This is what arctan is. I don't want to explain it far because again calculus. But basically, there are some functions like logarithms, some exponentials, trig functions. We can't solve them just by adding, subtracting, multiplying, and dividing. Okay? If I ask you what the sine of 45 degrees is, you're probably going to be like, okay, here's a little triangle. Triangles aren't multiplying, dividing, adding, or subtracting. You know, it's a triangle. So some really old smart men were like, okay, let's make an infinitely long function that represents all of these things. This is the one for arctan. Okay? It can go on forever and ever following that pattern we looked at earlier. It's just instead of x, we had 1. Now we have x. But what if we had 1? This is exactly what we just added up, like a bunch of times, okay? So then, remember what we said. If the tangent of pi over 4 is 1, what does that mean the arctan of 1 is?
Pi over 4.
Pi over 4, because it's just the inverse, you know? We love that, okay? So if we set this equal to this, because we know the arctan of 1 is pi over 4, we can set this whole thing at 1 equal to pi over 4. So we can set that equal to pi over 4. It's probably kind of hard to see for some people. So then we can just multiply the 4 to the other side, like we were solving for pi like a variable, and then we get this little expression. If you type this into your calculator, you're going to get like 2.98 something, a number that's like a 7% error off from pi. You know, it's close, but it's not close enough. How could we get this number to be even closer to pi? Any suggestions? Not you, you already answered. You already answered. Someone else.
Nick?
Keep adding. Yeah, keep adding. Keep adding. So if we kept adding more and more terms, what would the next term of this be? What would we add to get it closer?
Plus 1, 9.
Plus 1, 9.
You already answered.
What else would we do? After plus 1, 9. Minus 1, 11. Y'all are so smart. Oh my god. So the closer and more of that we do, the closer we get to pi. If we did that to infinity, we would have pi. Okay?
Yay.
That's a cool little thing. So this is just representing that we're going even further. For some of you nerds out there that might want to see the summation, it's right there. Doesn't really matter if you don't care what that is. It's not that relevant unless it kind of is at some point. Yay, calculus, woo! But yeah, that's just a cool little thing, is that pi over 4 is equal to that whole thing. Multiply by 4, pi is equal to this whole thing. Do we have any questions about pi? Any questions?
How many digits do you know?
What's your favorite kind of pie?
I don't like pi. 4. Anyone else? No? Amazing! We know pi! Okay, moving on.
Was it my turn? Okay, so the next one makes sense. Okay, we're going to be learning the Archimedes method. We all know that 2, or pi is greater than 2, but smaller than 4. But how do we know that exactly? Let's have this circle, right? Diameter of 2. What does that mean its radius is?
1.
1. Okay. What's the area of the circle then? Pi. Okay, so we know that the area is now pi. Now, let's make a perfect box surrounding it. The length is 2. What is the box size, or I mean area? 4. So now we know pi is less than 4. Now let's add a radius of another one where the square is perfectly encapsulated inside of the circle. Now, what's the area of the square? If the radius here is 1, and the radius here is 1, what is that?
1.
Wait. You know what? Pick up a hand. Nick.
It's 2.
It's not 2.
The area is
Oh, the area is 2. Yeah, I thought you meant one of the side. I'm sorry. Apologies. So now we know that pi is in between 2 and 4. How useful is this? Not very useful. Okay. So let's have another circle. We know that it's smaller than 4. But let's keep adding sides. The radius there is now 1. Sorry, I need to get some water. Water break, everyone.
Hydrate.
Yeah, hydrate, everyone. Actually, good. I need a third. You're going to be my third.
That does not count.
Everyone done drinking water?
Are we hydrated?
Okay.
Big water.
So we split this into 6 different sections since it's a hexagon. Make it into triangles. Could you actually no, you're fine. What is the angle of this? They're split up into 6 equal sections. It's 60. 60. Could you draw 60?
Yeah. 60 degrees.
Yay!
Since these have the same exact length, this is also 1, this is also 1, meaning these two will have an equal angle size. Yeah, there we go. An equal angle size. If you add up all the angles to a triangle, they all up to 180. Meaning this will be 60, and this will be 60. Yep.
Equilateral.
Meaning it's an equilateral triangle. What's another special property that equilateral triangles have other than all of the angles are the same? All the sides are the same. So I think I could actually. Oops. Did not mean to show that. Oops. Spoilers. Yep, that's a 1. Now, we could do all the math and split this in half, 30, 60, 90 degree triangle, and then multiply it by 12. But that's an unnecessary amount of work. Because since pi is just circumference over diameter, and this is 1, and there's 6 sides, we can just put a 6 in there. 6. Yep.
Right here.
Yeah, 6. That's the circumference. And pi is circumference over diameter, and we know the diameter.
What is our diameter?
2. That's how we get to 3. Now, eventually, we'll get smaller and smaller, and we'll get close to 3.14 something. You guys want to solve one?
Sure.
Now, another special property is that we can also get the square to be smaller. So I actually have 2 problems for you to solve. There we go. Those are the 2 problems. Don't be scared of the 96-sided polygon. It's actually not that bad, I promise.
It's only 96.
It's only 96. It could have been 97.
98 even.
98.
Please put on a little dance for everything.
Yes, definitely.
Steve, you should be a talk show host.
I know. What do you mean I am? Thank you, Olivia. Thank you.
You're welcome.
The 96-sided polygon is not pictured because it will look like a circle.
Because there's a lot of those.
There is a lot of sides of 96.
How many sides are there?
Only what?
Sides are there? What's the angle of each of them?
Yeah, Spencer. I knew that one. The day was.
That one.
Mustache.
No, my dear.
Oh, that was me.
How we doing? Are we doing that?
I got you, Steve. Little cheerleader over here. Oh my god, I still think it's fine.
Where are you getting that?
Let's give them a little hint. Yeah, give them a little signs are there. Hexagon.
6.
Okay. Can you draw something here? Yep.
That's not.
Okay. So this is 6 degrees, right?
Yeah.
Can you bisect this with a
Ooh, geometry term.
Whoa.
Can you put 30 degrees in here? Nope. Oh, actually, no, that one works. Going for it.
It's a bisector.
Since this is bisecting, so what is this? It's 90 degrees. 90 degrees. Can we put 90 degrees here?
Look.
This is the radius as well. Could you put a radius equals 1? Does this triangle look familiar?
Yeah.
What is it?
30, 69. Yeah.
You should be able to solve by then. You guys are all in math club, right? For the 96-sided polygon, I think that's one we should solve like together. I don't have the exact measure. Actually, I think I do. Wait. We divide 360 divided by 96. Someone give me that number, please.
3.75.
3.75.
Exactly.
180 degrees in a triangle. Can you draw a triangle for me, please?
A right triangle?
No, isosceles. 3.75 at the top.
Right.
Yep. So where the base is going to be?
What's the base of the
Where
triangle?
the angles of the base is going to be?
What does the top say?
3.75.
I say.
88.125.
Yeah.
We can do that.
Right. Divided by 2 is 3.
Math is nothing.
You got a 1 to the sides and 30 in length? Yep, 1. Yep, those are congruent.
And this is the length of
1. This is the radius. The radius is 1, so you're going to add a 1 in there.
Magic.
That's
Magic.
I haven't done the math class in a while. When is this time? No, but I can't remember which one it is.
Don't you have the answer in your slide?
Yeah, no, I don't have it in my slideshow. I'll do this off camera. Apologies.
We'll just say that we got it right.
3.141.
What was that? I'm sorry. This is a memory thing.
Steve, tell us the digits of pi now.
3.
Point.
That's it. Oh, you bisect
always miss stuff.
Bisect it.
We can always miss stuff.
Single is half.
Can't
Single
really
is half.
Could you draw a 1? Actually, no.
Oh, ew.
I should have probably made this a bit bigger. Oh well.
It's okay. You did a great job,
We
Jose.
did a great job. I have the answer somewhere. I did the math. I forgot how to do it.
We were supposed to watch that.
So sidetrack quiz. Did y'all know that if you put these numbers in order, according to an engineer, these are all the same?
Whoa.
Yeah.
Yay.
Move.
It's 3.1408.
Good job, Hosmar.
There we go.
You did it.
Equals what?
It's approximately pi. Or it's less than pi. Less than pi, not approximately pi, less than pi. Yeah, that's how they figured out that pi was 3.15. Archimedes did that 2,000 years ago. That's about it. You have anything else to add?
Now it's time to eat pie. So slowly and orderly, there's 6 different pies back here, thanks to people who are in the room. So come on in and grab
Yay! Hashtag pie. What is this?
I need a bigger triangle.
Alright, thank you, Hosmer and Spencer, for that great presentation on pie. So this past weekend we also had a chess tournament. Spencer was part of. Not Spencer, Hosmer was part of. So congratulations to those winners, Hosmer, Philip, Jacob, Tyler, and Shang. And this past Tuesday we also had a music concert. So let's go ahead and check out some clips from that.
Everyone did very well in the music concert.
Thank you to our wonderful musicians for giving us such a great show. Also upcoming, if you want to sign up at the 20th, everyone is hosting a free cornhole tournament
For the FFA food drive, because we all donated so much food.
Yes. So
proud of
if you like cornhole, go ahead and sign up. It is free to sign up. Sign up by the 20th. It runs 26th through the 28th in ARC. So make sure you sign up for that.
And it's free.
Also, if you're looking for some volunteer hours, make sure you check out the summer STEM camp that runs from July 7th to July 10th. If you have more questions about that, you can contact Mrs. Mom. Her information is on the Gettysburg website, so make sure you check that out. And then also upcoming on Monday, we have St. Patrick's Day. So make sure if your friends aren't wearing green, you pinch them.
Or if they're a ginger, naturally, we can pinch them.
No, it's the other way around.
No, I think that we should pinch all gingers. Cough, cough. Like someone who I might be standing next to.
Cough, shut your mouth. Anyway, here's Hosmer to comment on this pie.
What?
How's your pie?
It's awesome. I was about to say something bad. I realized I can't say that anymore.
How's pie?
It's good.
What flavor are you eating?
It's blueberry.
What's your favorite color?
Blueberry.
Blueberry?
Yeah.
What personality do you think the number 5
Irrational. I'm hilarious.
Oh, that's a knee slapper right there.
I don't want that.
Hosmar the comedian.
Alright, well that is all we have for you today on the Warrior Wire. Thank you for those of you who are tuning in, and happy Pi Day. Go Warriors!